So we're today with another video where I'm going to showcase a little bit something that I've been working on. Okay, so if we go back to Magicka for a moment and start up the game, right? You may see things look exactly just the same that they did last time we played, right? And you might be 100% correct. I did not make any changes to the logic or anything like that. But I did add a few quality of life changes to the way the data is generated. So if I go around here where this tree is located, you might think I'm not doing anything worthwhile as of now, but let me explain. This tree right here is an extremely high poly model for something found in Magicka, to be honest. Has right now about 15k vertices in Blender, right? And when it was exported, it exported with over 18k vertices as of now, right? You might be wondering why. I'll explain. Basically, the UVs in Blender, right? If we go over to Blender and check out the UV data for this object, for example, let me minimize some stuff on my other screen. So this box right here, for instance, if we go to UV editing, you might see that it has, well, a pretty basic UV setup, right? But if we select this face right here, where you can see that I've got laid out on top of each other those faces of this object right here, you will see that if I only select the part that corresponds to the tarp, part of the UVs are located over here, another part is here. We got plenty of disconnected pieces, right? You might think, well, just another day in Blender, right? What is weird about this? Well, there's nothing weird about this. It's just that this is not how graphics cards work exactly. Graphics APIs, the way that they work to be so fast is that they have UV data for each and every single vertex, right? So basically, by default, UV data is stored per vertex. But this is kind of limited if you think about it. I'm sorry for the noise coming from the street. Anyway, this is kind of limited if you think about it, because we would not be capable of having UVs like this, right? Because that would mean that every single piece in this UV would have to be connected on every single vertex. So these vertices right here would need to be connected to these vertices from which they come from, right? Because if you see, this is a single piece, right? So these two faces would have to be connected, but they are not, right? And why are they not connected? Because Blender has a very cool system where it stores the UV data per face, right? And this allows artists to create UVs that are far cooler and more powerful than if you only have vertex data. If you only have UV data per vertex, right? Because now you can have stuff like this, where you got this face located over here without caring about this. And how is this achieved internally? Well, from the point of view of the geometry made by the artist, these two quads are completely connected when I edit them in Blender, right? But in truth, when you look at the buffer that exists with the vertex data under the hood, these two vertices, as they are going to be fed to the graphics card, are actually separated, right? These two faces are not connected in truth, right? They would only be able to be connected if they shared the exact same UV data for these vertices between faces, and they don't, right? So this is the way that the meshes work in Magicka as well. And I didn't want to be losing the powerful UV making that you get out of Blender. So since we cannot exactly have per face UV data out of the box, because there is no way to tell the engine, because there are other engines that do have this per face UV stuff, which hides all of the work under the hood for the user, right? But Magicka doesn't have that because it's made in XNA, and XNA only offers per vertex UVs as far as I know. Maybe I'm wrong, right? But basically the way that that I did it at first was by simply going ahead and just duplicating each and every single face, right? So every single vertex located within every single face would be duplicated, and at the end of the day, if we looked at the resulting model that we would get in Magicka, it would be something like this, where every single face is just a separate piece, right? So that's how things would be. Basically, we would separate each and every single piece to allow each vertex to be duplicated, and since each vertex would be duplicated, we would simulate and conserve the exact same thing as the UVs per face, because we still have UV data per vertex, but we now have duplicated vertices, so we retain the exact same result because every single face is going to have its own vertices now. Obviously, this was not going to be the final idea. I was going to change that eventually, and the time has come for me to change it, and that's what I've done. And why did I have to change it? Because this is not very efficient, especially the larger the models get, right? One of the main problems that it has is that the export times are massive because it has to write a lot of duplicate data. And that has been fixed because I made a system to deduplicate vertices. So how does this work? The idea is that if we have this vertex right here, we think about it, this one in the middle, it's not really separated if you think about it, right? Like, not only is it connected in the faces, but if we come to this UV map right here, this vertex in the middle is exactly in the same place. So even if we have 4 separate faces, these vertex, they will all share the exact same data. They will share the same position, location, rotation, its same tangent, normal, and UV data, right? So that means that we don't really want to break up the geometry in that location, right? We want to preserve it in there, and since we want to preserve it in there, because it would be absurd to duplicate this vertex that is pretty much the same everywhere, right? What we can do is make a map of vertices and only add new vertices once we verify that the vertex is not in the map, or that if it is in the map, the one that is in the map has a different UV coordinates than the one that we're trying to add, right? And if we look at this right here, we're looking at the tree right now. This is the mesh tree. Like if we go over here, this tree right here. Let me hide the collision mesh a little while. So this tree right here, if we select it and we go over to the layout, it has 15,000 vertices, right? And when I exported this, it would go to over 38,000 vertices or something. I don't remember. Maybe it was 80K. I don't know. It was an absurd number of vertices because we were basically triangulating every single face, and then each and every single triangle that we would generate, we would be making duplicate vertices for it, right? And this allowed to have perfect UVs, obviously, but it's a big problem because it's basically forcing the mesh to, you know, have a lot of duplicate data that it doesn't really need to have, right? So the way that I got rid of that problem is with this piece of code. So originally, this is what the code looked like. Very simple. We have a list of vertices, and every single time we find a vertex, we put its position, normal, tangent, UVs, and we append it, right? And that's not a good idea because what we're doing we're looping over every single polygon in the mesh. We triangulate it up here, right? So we go over every single triangle and we just pick the vertices. And even if there's shared vertices, because we get the vertex index, this could very well be a vertex that is shared with another face and has the exact same data, right? But we're still copying it in here. We don't care. We just add another copy, and that's not a good idea. So the way that I solve the problem is by adding this small bit of complexity right here, which is a small map, which I want to modify because right now the way that it works, this is the key to everything, right? Basically the map, what it does is that if the vertex is not in this map, we use the real vertex index as the key, by the way, right? And we point to a list with all of the possible vertices. What we basically do is go ahead and add the new vertex, right? If it's not in the map, just create the new vertex. And if it's already in the map and it has the same shared data, then we do nothing, right? If we found that within this vertex index there is a version of this vertex within the map that has already existing UV data, we don't make a copy, we reuse that vertex that we already found, right? Because we now start a global index within it, by the way. That's why I get property 0, but anyways, but yeah, that way I prevent wasting any information. And we can go ahead and create a new vertex if we find out that there is no matching vertices within the list, because we have the same vertex but with different UV data. Now, another detail that I want you to look at is this thing right here. This is where the main condition is located. It is programmed in such a way that we could change everything. This right here, list entry 40, 4 is a property for the UVs, index 4. This is index 0, 1, 2, 3, 4. It's very simple, right? What we're saying in here is that if the UVs don't match, then we add a new entry. But this is so cool, actually, in the way that it is programmed, that we could modify this condition. Because right now I am thinking, what would happen with different normals, right? Because, for example, we're doing it on different, you know, UV data, but what will happen if we have different, you know, normal data, right? So that's something that we need to think about. And we can go ahead and make a new map, right? And we've got this cube right here, and we're going to export it, right? We can go ahead, go to downloads, export this, and once we got it exported, if we look over here, we got only one model now because it's updated the file. And if we look at it, we got 14 vertices, right? Why 14 vertices? Well, it should be only 8, right? Well, if we look at the default UVs offered by Blender, there's 14 vertices in the UV data, right? Pretty much, that's all there is to it. So all shared vertices are going to have, you know, their own stuff. But if you think about this, right here, these edges that we are selecting, if we go ahead and pick this on this face, what would happen? Because they have shared UV data, right? But they have a different normal. So the only way to get a sharp angle is by actually separating this face into a different one, and that's a problem that I'm going to fix very easily by just adding on that check that I showed you before on this if statement, if the normal is not the same, and we could also add if the tangent is not the same, whatever we want, right? Although I do have to admit that I have not seen this being a problem in Magicka, so I'm not entirely sure if I should do this, because this would increase the vertex count, right? But at the end of the day, we have a tree that has like 14k vertices. It exports as 18k vertices or something like that, right? And before it did like 30 something. And the reason I walked around here in game before is that since this tree had so many polygons and so many vertices, it was wasting so much data in memory for such a simple mesh that it actually caused the game to crash sometimes. Like, I got really lucky when I was recording before the AI pathing stuff. Later I came back to test it this morning and I kept crashing every time I came close to the tree, and the goblin was following me, and it didn't make any sense until I realized, holy shit, the tree's got a massive amount of vertices, right? And I deleted the tree, it worked just fine, and I decided to solve this problem, right? So yeah, that's pretty much all there is to it. So if we go over to any of these, you can sort of see that, yeah, it makes sense. Here we got the sim for the the normals, but in here it seems like there's no change in the normals, so it would make sense to add that extra check. Yeah, I suppose it would make sense, because then if we have a smooth surface, it would work out properly, like I'm not sure if it's a good idea or not, but we can do that, right? So we basically have this thing right here, and we can just go or this. So list entry of they don't want those. Okay, and we need to add another entry for normal 3 and list entry to normal 2. Right, so we got the normal 0, normal 1, number 2, right? And if we go over here to preferences, we can, whoops, go ahead and go to Magicka exporter and uninstall this, install it again, go to the add-ons, add it up, and we can file, export this JSON into downloads. Okay, we open this up, we've got 14 vertices, nice. And what happens if we go ahead and say create, oh, actually this condition should be an and if I think about it, right? Because for a vertex to be matching, you should have the same UVs and the same normals, right? Okay, that makes more sense. Sorry for that mistake, because I was like 14 is still, it should be more, because we got flat faces in here, so we need those to be different UVs to get that effect actually. So anyway, let's just export this file over to untitled again, and if we check it out, we now have 24. Yep, 24 indeed. And if you think about it, we go over in here and we've got you know, how many faces does a cube have, right? And how many vertices each face. You multiply that and that's what we get, right? So that's correct indeed. And now if we go ahead and we go object shade smooth, right? The vertices are going to have, I think they should have the same smooth out normal, like going in diagonal here, right? And if we go ahead and export this to here, we should get 14 again, probably. Yep, we got 14. So we would only get 8 if we didn't account for UV information, and since we do account for UV information, we get 14. So that's it. Pretty cool, because that means that if we have a shape like this, for example, right, and we want this to be out smooth, right? So this whole face set of faces right here, this side is completely smoothed out, but these edges are, you know, straight, and they are sharp edges, right? So rather than duplicating each and every single face in here, we only duplicate the stuff where the sharp edges exist. Although in this situation we would get the exact same result, because if you think about it, we look at the UVs and we only share 2 vertices in there, and the normal is like basically we have these vertices in here, so we wouldn't gain anything in this situation unless we had some form of detail here like that. Like then we would actually have a boost in performance in this situation, right? So this is all, if you think about it, stuff that you should be able to configure. Like it's cool for it to be automatic, but I think that for the next update I will be making some kind of controls in the Enki panel for Magicka to allow you to select for every single mesh how you want it to be exported. Because if we go back to our map now and we try to export it again, right, file, export this thing to untitled, well, we're gonna lose the texture data, but it's taking a while longer actually, because if we start closing these root nodes and go to the last one, it probably has more vertices now than before. And well, we do have 18K. That's actually, I think it's the same amount, because yeah, it's the same amount because the entire tree is actually smoothed out. There's no sharp you know, edges except where the caps end. So the tree is exactly the same. What changes is the rest of the geometry because it's all shaded flat, right? So at least now, if we go over to UV editing and select this face, for example, right? Oh, it's true. Okay, I get it. We didn't get the problem in game. I was kind of surprised because I was like, what is the UVs that we have? I forgot that I had modified the UVs myself. That makes sense. Yeah. That's why we didn't get the problem. Although we did have this kind of problem here where this face and this other face would be laid out together and these vertices are connected. So we did have a few problems regarding the shading, if you think about it, because this face is this one and this one is this one, and they are laid out side by side, but they actually are not really connected. So this was obviously giving us the wrong UVs before I made this fix on video, but we didn't really realize them because one side is not visible for us. So probably since this face looked okay, we were picking its normals and basically overriding these ones right here. Or not really, because actually they have different vertex indices. That's right. Yeah, so even though they're connected, the vertex index is different. That's why we didn't get the problem. Okay, yeah. So the only problem would be possible actually if we had kept the regular UVs. I'm not sure if this is really a good change what I've made in here, because we probably are going to get more duplicate geometry from now on, but like I feel like preserving the correct normals is the way to go. I don't know, you guys tell me what you think, because this is how I'm going to leave it for now. I think it's pretty much wrapped up, right? There is not much else for me to showcase for now. It's just, you know, now you can have larger models in Magicka without worrying about performance, and you can even keep their UVs as cool as you want, right? As I said before, I'm probably gonna add an option to completely disable, Blender style UVs, because I don't want them to give us any problems. So that's gonna be it pretty much. Yeah. I'll think about it and see how I cook this stuff right up. So yeah, see ya.